All right, we are rolling. Hi there, this is Judy Mizraki again. This time with homework 3. Sorry about that, Judy. Can you see this? Mizraki. Okay, and of course this is EL6303. The question says, the customer flow at a grocery store can be viewed as a Poisson process, okay? And this is the equation we're given. The probability that in the time interval 0 to t, okay, k customers arrive, okay? And this is equal to e to the minus lambda t to the k over k factorial. So obviously lambda is going to be some constant, okay? And we're given, suppose the probability that in 2 minutes, so the probability that t equals 2, at least, one customer arrives, so k is bigger than or equal to 1. And this probability is equal to 1/2. All right, so what does that tell us? Well, since k has to be greater than or equal to 1, and all of the way that this function works is that for each k, sorry, this should be a t over here, for each k and t you get a single output. That means we have to sum all the probabilities that of k being equal to 1, k being equal to 2, k being equal to 200, all the way up through infinity, okay? So if we want to set these equal to solve for this constant, we have to take the sum from k equals 1 to infinity, okay, of e to the minus 2t, 2 lambda because t equals 2, of 2 lambda to the k over k factorial, all right? But we recognize this here, okay? If we look at this as 2x to the k over k factorial, if we take that sum, since this is just a constant, we know, you can look it up in an integral chart or whatever, or a summation chart, whatever it is, but we know this equals to e to the 2 lambda minus 1. I looked it up beforehand. I don't actually know that by heart, sorry. And if you multiply it through, you get 1 minus e to the minus 2 lambda, and obviously that equals 1/2. If you have any trouble following that, just kind of, rewind and just kind of look it through, but this ends up being true. So again, we subtract 1/2, we add this, we get 1/2 equals e to the minus 2 lambda, which is just 1 over e to the 2 lambda. So of course that means that e to the 2 lambda equals 2, which lo and behold tells us that lambda equals ln of 2 over 2, or 2 over, 1 second. Let's see, sorry. 1 second. So if we take the ln of both sides, we get lambda equals to the ln of 2 over 2. Awesome. And if you plug that into your calculator, which I already did, you get this to be equal to about 0.35. All right, awesome. So now so we have a lambda. So for part 2, we're going to use this equation to solve for other things. So let's go ahead and plug this into this equation to see what we actually have. So we have e to the minus ln of 2 over 2, t, times ln of 2 over 2 t to the k over k factorial, and this is our probability. But notice, okay, with t and k, notice that this here is just going to be equal to e to the ln, right? E to the ln of 2 is just 2, and then of course to that higher power. So this just becomes 2 to the minus t over 2, okay? So then this whole thing becomes this. All right, awesome. So we've got a nice little equation there, okay? That being said, we want the probability that oh, by the way, I chose t in minutes. The reason why we have this lambda is it's kind of a conversion factor for, if I chose t to be in seconds, I would have gotten a different lambda, because notice it's always multiplied against that t. So, this is kind of a nice little thing, but it's convenient to use minutes. So find the probability that in 10 minutes, t equals 10, at least 2 customers arrive. So k is bigger than or equal to 2. Well, this is really easy because, again, we're going to have to sum because we have a bigger than or equal to sign. So we want the sum from k equals 2 to infinity, okay, and we're going to plug in this for t, of 2 to the minus 5, right, because 10 over 2 is 5, of ln, well, actually, you know what, again, we'll just say 5 ln of 2, because, again, 10 over 2 is 5, so 5 ln of 2, not too bad over k factorial. Now, like I said, I already plugged this one as well into a calculator, or Wolfram, I think, actually, I used for this. And I got, what did I get? Let me just check what I got. Sorry about this. Hang on 1 second. I did write it down. I really did. Let's see. Oh, here we go. Yes, I got, when you sum this whole thing up, if you put it all together, you get around sorry about that, this whole thing is going to be about 0.86. And by the way, that makes sense because if in 2 minutes you're half as likely to have at least one person, it makes sense that in 10 minutes you're more than likely to have 2 people. So it makes sense, this is about 86% chance. Okay, awesome. Let's do number 3 now. This is just easy. Find the probability that in 1 minute, okay, exactly one customer arrives. Okay, equals 1. Well, this is very easy because we just have, you know, one thing, one solution. So that's going to be 2 to the minus 1/2 times the ln of 2 over 2 times t, which is just 1, to the k, which is 1 over 1. So we're just going to get ln of 2 over 2 radical 2. And this is going to be approximately, well, I think it comes out to like about, what does this come down to? I think this comes out to about like 1/4, something like that. Let me just check it out 1 second. Oh, actually, no, this comes out to be, yeah, this comes out to about 1/4. About 0.245. And the reason why that makes sense, by the way, is because, you know, it makes sense that if more than one person is going to arrive in after 2 minutes is half as likely, 50% chance, then it makes sense that it's about 1/4% chance that one person, you know, arrives in 1 minute, because it's, you know, more likely that 2 people come in 2 minutes than, or that one person comes in 2 minutes than 2 people, more likely that 2 people than 3 people, etc. So this is a logical answer. You can still see that. And finally, number 4. We want the probability that in 3 minutes, no customers arrive. So k would be 0, all right? And this is just going to be equal to 2 to the minus 3/2 times ln of 2, let's see, we have ln of 2 over 2 times t, so this is going to be ln of 2 times 3/2, but this is to the 0, so this whole thing equals 1, over 0 factorial, which of course is also equal to 1, so this is just going to be 2 to the minus 3/2. All right, and that's about equal to 0.35. All right, awesome. And that's all, folks. Have a great night.